the young generation of scientists. And then before the coffee break, we will have a talk by Geraldine Cochrane that I'm going to introduce to you later. And the title of her talk is Environmental Injustice and the Need for Physics for and by the People. So then we will have the coffee break and we will be able to chat. And today the schedule is less tight, so it's not so bad. I mean, for today's schedule that we are having this problem now. And we will have time to discuss all the ideas we got from the very interesting talks. So,
Silvina, if you wish, I can start.
Okay.
While you
okay.
find my
yeah,
PowerPoint.
Sure. If you
I hope you find it, because I wouldn't like to speak too much. I've been aphonic and my voice is terrible.
I see. I noticed.
I apologize.
Okay, so here it's coming on a pen drive actually that is being placed in the computer. But if you want to start before showing any image.
Okay. Yes, of course. Well, I would like to start by thanking you and Igle for inviting me to this intercommission session on a very important and timely topic, nuclear weapons production, control and threat. And I would like to start by referring for this purpose to some text from the program of this symposium. Namely, it reads, humankind faces major challenges that endanger our future and civilization as we know it. Global challenges for humanity include sustainable development, global warming, energy, natural resources, pollution, clean water, and the uncontrolled development of artificial intelligence. And solving these problems needs scientists, among others, to raise public awareness. But surprisingly, the text does not mention the nuclear threat, which is evidently there. We cannot ignore it. So, to set the framework, I would like to remind ourselves of some words, some statements were usually recently made by the UN Secretary General Antonio Guterres. He said that disarmament is an essential tool to secure the world and our future. And
let me tell you, Ana Maria, we have your talk being
okay.
So you can, when you want to pass from one
on slide 2, please. You have slide 2.
Should I go to the next slide? Oh.
Yes, if you have slide 2, the next slide.
There. Here?
Okay, the next one, slide 3, because this one, yes.
Okay, great.
So Antonio Guterres reminded us that nuclear weapons continue to be a threat to humanity and to our planet. And he further called for urgent measures for the abolition of the nuclear weapons and the end, because of the threat to annihilate the human race and our environment. And for this reason, he called for a constant dialogue as a powerful weapon, another kind of weapon, as trust and dialogue are integral parts of human dignity and a precondition for lasting peace and security. Certainly, dissuasion is not a good condition for lasting peace and security. And that's the time, the new Cold War time, I thought, by the way, that we are living today. So if we go to the next slide, more recently, just 3 weeks ago, the Pact for the Future was signed by the member states of the United Nations. It was adopted at the recent summit. And I'm taking some excerpts from that Pact of the Future. It's a very long document. It covers a broad range of themes, but I will focus on actions 25 and 28. Action 25 reads, we will advance the goal of a world free of nuclear weapons. And for this, we reiterate our concern over the state of nuclear disarmament, and we recommit to the goals of the nuclear total elimination of nuclear weapons. And then Action 28 says, we will seize the opportunities presented by science, technology, and innovation for the benefit of people and the planet, and we will be guided for this purpose by the principles of equity and solidarity, and promote the responsible and ethical use of science, technology, and innovation. So I ask myself, what does this have to do with us, with physicists? And my response is a lot. Physicists are involved in the entire nuclear weapon cycle, from the conception and design of the nuclear weapons to their diffusing, to their full destruction. In every step, you find physicists involved. If we go to the next slide, we'll see a quick review of what IUPAP has said about nuclear weapons. What has been the concern of IUPAP since its creation? Well, we start with the very noble mission of IUPAP as it reads. It is to assist in the worldwide development of physics, to foster international cooperation, and to help in the application of physics toward solving problems of concern to humanity. It further reads that IUPAP rose, it reminded us, it rose in the ashes of war, as recently published by Lally and Navarro in Nature just 1 month ago. Nobody thought of nuclear at that time when IUPAP arose in the ashes of war in 1922, after World War I. However, after World War II, the development and use of nuclear weapons significantly changed the public image of physics. Physicists are now seen as integral to state power and security. Despite the Atoms for Peace campaign, which was seen all over, no way the stigma of nuclear stigma can be brushed off the physics community. However, throughout its first century of existence, since 1922, and including the so-called difficult decade of 1937 to 47, IUPAP has kept its distance from issues related to nuclear weapons. In fact, it has kept silent. None of its 19 commissions or its 4 affiliated commissions deal with the subject. This is how we are today. In the next slide, you can see the current landscape regarding world military expenditure by region. We have the green region are the Americas, then the next region is Asia and Oceania, then comes Europe, and then comes the Africa and the Middle East. You can see how it has been increasing steadily in the last 10 years. Indeed, the world military expenditure by region is an enormous expenditure, enormous. In the following, I give some details about it that are relevant to us. Namely, nuclear efforts are being developed in one country to replace modern weapons in other countries. There is a transfer of nuclear weapons from nuclear weapon states to other countries. Then nuclear arsenals are being modernized by the nuclear weapon states. And also they are being supplemented by powerful, what is called conventional, that is non-nuclear, long-range autonomous weapons with very precise geolocalization capabilities. We know that from the newspapers today. These are conventional weapons that destroy target more effectively because of their capability to localize them exactly. The world expenditure in military science and technology has benefited from a significant increase these last 10 years to over $100 trillion per year. That is 10 to the 11th power US dollars per year since by last year, 2023, which is the latest figure. It is difficult to find figures for each and every country, nuclear weapon states declared or not. But just from the figures that one can find, one can see that just one country alone spends at least $18 trillion in science and technology, and nearly another $2 trillion additional on artificial intelligence for military purposes. So this is military funded research and development is physics, is a very high percentage of the total of the entire research and development especially in the nuclear weapon states. Much of this is used to fund the infrastructure, the research infrastructure, the laboratories, equipment, personnel, as well as, of course, the big commercial journal publishers, the consortia. They live to a high percentage on this military research and development money. An unavoidable conclusion is a high percentage of physicists depend on nuclear funding for their research and even for their salaries, for their earning. Now, not all goes into nuclear weapons, and not all is used for defense purposes. But let us not fool ourselves. I mean, things like precision technologies for geopositioning, new materials, powerful lasers, these nanostructured materials in particular, they are also developed for war purposes, not just for peaceful purposes. And physicists are involved, knowingly or not unknowingly, willingly or not unwillingly. So, the next slide, I go back to a statement made by the IUPAP General Assembly in March 2022, just a bit over 2 years ago. And it reads, no scientist should be excluded from union-sponsored conference as long as he or she carries out work not contributing to weapons development. This is a very strong statement. And I would add to this something from a note published by Pepe Altarelli and James Regan a bit later, a few months later, in the CERN Courier, in a note under the title 100 Years of International Collaboration in Physics, which he published to commemorate the IUPAP centenary. It reads, no scientist shall be excluded from the scientific community as long as their work is based on ethics and the principles of science in its highest ideas. An aspect that certainly will be further elaborated by the Working Group on Ethics, the Working Group 18, which also was established not long ago by the IUPAP General Assembly. Indeed, the Working Group 18 started its work about 2 years ago, and it presented its first review in 2023 in October to the General Assembly of the existing codes of ethics. This was
let me interrupt you a little bit here, Ana Maria, because
yes.
I forgot to say at the beginning that you are the chair of this working group for IUPAP. Thank you.
Okay, thank you, Elvina. Yes, well, we worked on the first year on this review of the existing codes of ethics of not just physics societies, but also other scientific societies. And this was presented already 1 year ago, and you can consult it. I'm sure you can see that the issues are grouped under 3 categories: research issues, the physicists interacting within the community, and physicists interacting with the rest of society, as was presented 1 year ago. But it's interesting to point, because we did not point it out at that moment, that nothing is said with regard to nuclear weapons production in all these codes of ethics that were reviewed. Nothing about nuclear weapons production, control, threat, diffusion, nothing. That was very surprising, at least to me. But a more stimulating surprise is what I recently discovered, and that is presented in the next slide. Namely, there is a project sponsored by the American Physical Society to engage physicists in reducing nuclear threat. You can find it in the websites that are written down at the end, at the bottom of this slide. And the main purpose of this project is to develop ideas on how the physics community can influence the policies and postures of the nations that possess nuclear weapons. And it recognizes that physicists have a special relation to nuclear weapons, historically, of course, and technically. Thus, physicists' views as citizen scientists, not only as experts, can potentially have an influence, as stated by Stuart Prager, who is from Princeton University, who is the chair of this project. So, as a conclusion, and we can go to the next slide, as a conclusion from this review, the Working Group 18 made some additional considerations. Namely, one is that ethical issues evolve and new conflicts arise as a result of the emerging technologies, of global challenges, of the spread of malicious practices, of growing inequity, social distress, changing political landscape, which add to the persistent issues. The nuclear weapons issue is a persistent issue, but at the same time, it is new. It is being renewed and renewed. We also consider that ethical standards cannot be carved in stone, but must be critically reviewed and kept up to date. For these reasons, and most particularly in light of the facts and the arguments that I have presented to you today, I propose that IUPAP should consider establishing a permanent ethics committee to deal, among other things, with issues related to nuclear weapons, and not just to policy issues, but also to the more practical issues related to their development, their production, their threats, and their elimination. So that is my proposal, which I submit to the consideration of this session and of the IUPAP General Assembly. Thank you very much, and apologies again for my terrible voice.
Okay. Thank you, Ana Maria. Do you want Eagle to have some questions now? Because there is some
yes.
time. Oh, no,
yes,
just because
course.
there is some time. I don't know.
Yes. Absolutely. Yes.
I'm checking with Eagle.
Yes.
What do you think? We are 10 minutes. No, she was supposed to start 2:20. That's what I have here. Please let me know. We are earlier.
We have been very efficient.
Let us have some questions then, please.
Yes.
In the back and in the middle row. Over there, please raise your hands.
But this professor is first.
Oh, he has?
Yeah.
So in the back, in the back.
Right, I just want to make a comment. Anna Maria,
Yes.
maybe you are not aware of, but we have 18 commissions rather than 19. The other thing is that Working Group 9 has often been associated with working on the nuclear safety. And I think there were reports of the WG9. Thanks.
Thank you. And what happened with Working Group 9 today?
It's still working, so issuing reports. But maybe they can, I don't know, liaise with the working group on ethics to work on this specific issue of nuclear weapons. So
Yes, but my point is that this is not this is a very serious issue, and I don't see a working group dealing in its entirety with it. I think it deserves really a permanent ethics committee.
yes,
More
but
broadly
that-
to deal with issues, no, not just nuclear weapons. But
No,
that's
no, no.
okay.
yeah, I agree that we need an ethics committee. So Nithya, please.
Thank you, Silvina. Anna Maria, thank you very much for your wonderful presentation. I'm Nithya Chetty. I'm the outgoing Vice President for Membership and Development. And I want to say that through my past 7 years, I have often wondered what role IUPAP could play in reaching out to North Korea. Now, obviously, this is a very sensitive matter, so there's not been any discussions within the IUPAP, but if you apply the principles that you've enunciated around the position that IUPAP takes, we engage with free circulation of scientists, the condition that they are not actively involved in weapons development. So I wondered whether you had a view. At some stage, I think, I mean, we can see we have a highly intractable problem in terms of North Korea, but perhaps the scientific community can establish a link, a collaboration that could begin to create some hope for a better future in the Korean Peninsula. Do you have any thoughts about this? I don't think it's something we should rush into at all, but just some quick thoughts on that.
Yes, well, in my experience, especially in my PAWASH experience, it is difficult to establish links with North Korea, but it is not impossible. And they can be established on a personal basis. But I mean, one has to be very careful. But I know some colleagues that have had a nearly constant collaboration with colleagues from Europe who have are in contact with colleagues from North Korea. And I think that would be the best way to start, because always a good collaboration start on a personal level, and then one can find, one has to have the right sensitivity to see how one can move forward. But we could explore possible contacts that exist already so as to move forward.
Yeah. Okay,
Yes, I think it's me.
maybe, well,
Yeah.
who has the, Pratval, you have the.
Thanks for that amazing talk where you've said things that desperately need to be said. I was wondering whether the working group could come up with some sort of best practices for both institutions and individual physicists in the direction of, say, more transparency in where the funding for their research comes from, and also maybe advice to young aspiring physicists as to what kind of career choices they make in this context, because it is also a fact that physics is losing talent because several young people are disenchanted with the engagement of physics with weapons. So
Thank you. So
Thank
we will have a discussion session later. So I would include now only some questions, specific questions, but
sure.
for the discussion, maybe for later. So I don't know if
But-
there's questions, Monica?
Yeah, A brief side comment, Anna Maria, this is Monica Pepe Altarelli speaking. I wanted to recall that Stuart Prager that you have from Princeton that you have mentioned in your presentation, who is a leader of the Physicist Coalition for Nuclear Threat Reduction, was invited to both our centenary celebration and also to the event organized at the March meeting of the APS last year. So, yes.
Yes, yes, thank you. Yes,
Yeah.
and with regard to the previous comment, which I found an important one, I hope we take it up in the discussion that will take place later.
So maybe one last question and then we move to the next speaker.
Hello, this is more a comment. Ebhard Wittmann from C12 Nuclear Physics regarding WG9. Actually, nowadays, WG9 consists of all the directors of all the big nuclear physics labs in the world, but there's nothing related to nuclear weapons discussed. It's all civil
Yes,
applications.
Okay.
yes,
Thank you.
that was my feeling.
Yes.
Indeed,
Okay.
yes.
So let us thank Anna Maria again.
Thank you. Oh, thank you very much. And we meet later.
Anna Maria, if you can please stay like an hour and a half more, because we are going to have a session with open questions and discussions. So if you can stay, that would be great. Thank you.
Well, what I have to leave now, but I will come back. Don't worry.
Okay,
I will
great.
be
Okay, if you come back, that's super fine.
in 1 hour or so.
Pardon me?
In 1 hour?
In an hour and a half. I think it's, let me see. At what time is it? At 4. Yes, it's more or less an hour and a half, a little bit less.
Okay. Yes,
Okay,
yes, you can count on me, sir. Certainly. Goodbye. Yes, see you later.
See you. Bye-bye. Thank you.
Bye-bye.
So we invite to the podium the next speaker is Cyrus Walter. You've seen him quite frequently here, participating very actively of all the discussions. He's a PhD student at the Technical University in Dortmund, Germany. He works on active galactic nuclei and on astrophysics. And he's also the past president of the International Association of Physics Students and also past chair of the affiliated commission number 5 on physics students. He's also the secretary of our IUPAP's working group on physics and industry. And he also works on developing new machine learning techniques for the analysis of the data he works with. So he's going to talk exactly about generative AI and what is the influence of AI on the young generation of scientists.
Okay, let's see to make this work here. Second. Okay. That. That I'll take with me. So, okay, hello everybody. This is indeed a talk on AI, and I hope also everybody online can see it. Let me know if that's not the case. I think that's the best that we can do. Should work out reasonably well. Okay, so hello everybody. This will be a talk on AI, and it will be specifically about Gen AI. What it will not be about is, it will not be a general introduction to artificial intelligence. I have to disappoint you, this will not be a random university course. This will be about something that people in AI normally don't talk about. So that is more Why is that plopping up? Okay, sorry. So that will be much more about the following topic, which is, let's see, well, this works, about what is the influence of, yes, thank you. I tried already, you know. So that is much more about what is the influence of AI on the young generation of researchers. Because what we often talk about is what is the influence of AI about anything else, but we rarely talk about what does it do to us, to researchers in general. And because I myself count myself still to the young generation, I want to talk today especially about what is the influence that AI has on the young generation. And of course, we do that in the realm of the Intercommission Symposium, and I'm standing here for Working Group 16, co-data, to which I'm adhering an executive committee, and the Technical University of Dortmund. So let's dive right deep into it. Artificial intelligence itself composes itself of a variety of aspects. So I looked around for a good definition. So I borrowed a little bit from the Oxford English Dictionary, and it says, artificial intelligence is the capacity of computers or other machines to exhibit or simulate intelligent behavior. On the other side, there's also a second opinion from the UN Regional Information Center for Western Europe that says AI is generally considered to be a discipline of computer science, and that is aimed at developing machines and systems that can carry out tasks considered to require human intelligence. So this is generally speaking, what we want to talk about today in this session. There are a few terms that I want to bring into this discussion that are generally used in the normal day-to-day business when you're not directly in AI development, that are used interchangeably with most often thought of as AI. The first one that we want to talk about a little bit, that you can't read now. It says buzzword bingo. Buzzword bingo is a term that refers to throwing around terms that you don't really know what they mean. They just want to use them because they're cool. And the first one of them is machine learning. Machine learning, according to, this is borrowed from IBM, is enabling AI to imitate the way that humans learn. A second one that is often interchangeably used, but also referred to, like often meant as actually AI, is developing computing that mimics the concept in which the human brain thinks. That is what normally, traditionally, is meant by neuromorphic computing, which is different from machine learning. Another one that are neural networks. That is what was recently in very big news. And it's actually making decisions by using processes that mimic the biological idea of how neurons work in the human brain. And then the last one that is just all over companies all the time is deep learning. And deep learning is using multi-layer neural networks to mimic processes, complex decision-making that happens in the human brain. And all of these four are completely different. So next time someone throws around these statements and these names, think about whether they really want to talk about exactly that, or whether they just want to talk about AI. That as the first basis on what we want to talk about today. Next, I want to talk a little bit about that AI comes around timely. Everybody has seen that. That is the recent image of the most well-known Nobel laureates that have just been awarded a few days ago. And the Nobel Prize in Physics goes for the foundational discoveries and inventions with artificial neural networks. I believe no one of us can argue the point more than ever, really timely. So if you have not so far engaged with AI and it just moved apart, like partially next to you, want to consider at least tapping into the fields of what AI does and where it can connect to what you're doing on a day-to-day basis. Secondly, interesting, I'm reconnecting to Zoom. Okay, let me reshare. Okay, we're back again. Okay, we're back at it again. Next point I want to make is it comes with momentum. There has been a lot of development going on in the world of AI. So what we currently have is we have a variety of papers and a variety of new methods that come in. That means there are diffusion models, there are generative adversarial neural networks, there are graph neural networks, there are normalizing flows, there's stable diffusion. There's a variety of really highly advanced AI models, and most of them really find their popularity now in the last 2 to 3 years. And that is a development. If you see these papers, the amount on what they're used these days, you cannot really ignore that at any point. So we've seen AI comes with momentum, AI comes timely, and AI is generally used, but most people don't have too much of a touch to it. And that, although there is a generation that is absolutely born into the age of AI. And that's what we want to talk about today. So we don't want to talk about the general timeline of AI. There are many people that can give you a history about how AI looked like. I want to talk a little bit about the timeline on how it looks for the generation AI, which are those people that grow up with AI in their lives naturally, as teenagers, as young scientists. And you might think, what is the first thing on this timeline? The first thing that came to me, to my mind, when AI went into the minds of this generation AI is the following. That was one too much. That's Snapchat. It's the development of Snapchat AI filters. It was the time when young students went to their phone and used the AI Snapchat filters. Don't know whether you ever had them, but have you ever wondered why they know where your head is and where they have to put the funny bunny ears? It's exactly because they have really good AI behind it. And now I want to do a test with all of you. So I'll notice who of you is not actually paying attention to me, but sitting here. I want for all of you to close your eyes. All of you right now. And then all of you now close your eyes. Please do that. Do me a favor. Close your eyes. All of you. And now raise your hand if you have ever used a Snapchat filter. Okay, thank you very much. Hands down, open your eyes. I can tell you it was less than half of the people. I'll not tell you exactly how many, but it was much less than half of the people. So that is something that is really, really towards the new generation. Next point that is exactly on the list is DeepL. DeepL is a translational tool that is really good in translating whole texts to a completely different language. You don't have to know English anymore. You know your mother tongue, you throw it in there, and it translates you out a big bunch of really good English text with perfect grammar. And you look at that and be like, I would have never known that these words even exist in English. And they do that very well. And that's since 2017. That's not so long. Next point on the list is the GitHub Copilot. Many people might have not heard about that, but if you're in coding, that's a very important tool. Because if you have to code, you have noticed that sometimes there are for loops, if cases, and you have to code them and it gets iterative. Some smart people thought about actually doing that with AI. So the AI tells you, you tell the AI, I want to do this. And the AI will give you suggestions for your code. And often code doesn't work immediately, but it's a very good basis to code much, much faster. I've talked to people who use that on a regular basis for their projects, and they're coding so insanely faster with that. And then the last one on the list is ChatGPT, because you can just go there, ask them any question, and they will give you knowledge. This is what we see as a timeline as young people that we want to talk about. And these are the areas where we have experienced in our life. I can tell you a little bit. When that came around, that area here, when that came around, I was 16. That was 18 for me. And that was most recently, I was 22 that year. So I grew up with that. That's the time that's absolutely natural to me. Using DeepL to translate something that you don't want to translate doesn't come as a new technology. And that is something that creates a lot of issues. So the question, if you grew up with that naturally, is why shouldn't we? And why shouldn't we, can you ask for many cases? For example, why shouldn't we write proposals through AI? Why not? Like, it's natural there. Why shouldn't we just use the tool that has always been there in our education to just write the proposal? Why not? I mean, nothing against that, right? Another question, why should we? Why shouldn't we stop handmade coding development? I can just do that with AI. It's just much faster. Why do I have to code at hand? I don't have to code by hand. It takes way too long, and then in the end that's really stressful. I don't want to do that. I can just do it handmade. Some people, that's how they learn coding. GitHub Copilot, they don't know coding. They just do that made coding. And why shouldn't we and stop attending conference in the first place? 6 hours to come here. There was not so much leg space. So I'm at home and enjoyed video games the whole time. Summary of the whole conference and just enjoyed. Would have been much less hurting. There are many reasons why you could do that. And then the answer, the actual answer of many people to that is, so why shouldn't we? And the answer is, we don't know. So we just do it anyways. So if that's the answer to these questions, then all of the things that we just heard, and I really hope you have some moments, you had some moments with that where you were holding back and said, no, whoa, this is not how it works. Some of this generation say, yeah, why shouldn't we? And if that's the answer, they will do that. And that comes with issues, not going on conferences, not coding by hand, not just translating your own texts. That comes with an issue. So next, we want to talk a little bit about arguments that encourage us to do AI. Except for making our lives easier, there is a bunch of reasons why we want to use AI, why it makes it easier for us. First is the young generation adapts very quickly. So if there's a new generation, new technology that we want, for example, we want a picture of something that doesn't exist, but I need a picture of an astronaut riding on a horse in a circus. For some reason, I need a stable diffusion model, and I tell him on a horse in a circus, and it creates me that picture. Of course, that picture has never existed, has nothing to do with any truth, but I need that, and this came out 2022, and I'm used to adapting to that, so I will use it if I need to. And they will identify whatever this new technology does very quickly, so they will use it not for what the original use was made, but for whatever it will be useful for. Second, the use of AI appears very natural. It's not something that you say, oh, now I'm using AI, so this is something special. It's just the usual stuff. There's peer pressure, because if everybody around you is using AI to make their presentations, and suddenly the presentations get much better, and the grades they're getting is much better, you will not use AI, because first of all, you don't want to be the worst in class. Second, why do I have to do the work myself? So if there's so much peer pressure because everybody's using it, I'll go with the flow. I'll use AI anyways. And then there's little regulation to it. I can just use it for whatever I want. Regulation, there's very little regulation on what I'm allowed to do and what I'm not allowed to do. So I can just go ahead and I can just anyways go and do whatever I want on a technology that it has not been used before, on a topic that is new to it. And I can just do it because I want to do it and I'm born with it. So is it the holy grail to just a really relaxed life? Can I just go with it and then I have a much better life? It's not so easy, and you probably come around with some arguments why it's not, because it is not. And now I want to talk a little bit about stuff that keeps us from just embarking into AI and doing nothing else, because the young generation is, of course, very tempted to do so, but it doesn't mean that we always have to do so. We also have our brains and thinking about the negative aspects. One of which is you lose your individuality. If you just put something into an AI, you lose your personal touch to what you've wrote more. And that is, of course, anyone can put into can put to the AI paper about 20 pages on stable diffusion. That has nothing to do with you have any of your skills. Anyone can do that. So the reputation of AI is so if someone finds out you've used, your colleagues will look at you very badly because they have written their stuff. Surely they have, but since it's openly known you have used AI, you're the bad person. AI often learns underlying to take out the physics that remains often complex. So you neural network, predict with AI neural network, but you cannot get the physics out of that neural network. That's a very complicated process. It's ingrained into the coding of the neural network itself there, and to form that is not so easy. Then science in the end is about struggling. All of us had the issue sitting there, nothing is working. I'm very frustrated. It's 2 a.m. in the night, and you still kept on developing and going forward and actually figuring out what the bug was. That is sometimes where the fun of science comes from. And if you decide for science, then most of the time that actually wants to deal with hard problems and that actually wants to get dopamine from solving them yourselves without any tools. So consequently, we end up visibly unsure about what we want to do. Do we want to do the easy life and take the Holy Grail? Or is it just a mock-up and we end up in unhappiness? What's in the end result? So let us go through a very quick conflict that could arise, just a thought process. Just you know, this is how a regular young person might think on one of the discussions. I need to advance towards a permanent position as soon as possible. Young scientists, often the thought. AI tools will make my proposals better and make me receive this vital funding that I need, because otherwise my life in science might be over. So I have to use it. Well, but if I use AI, am I even good enough to climb the academic ladder without AI? But if everyone else uses it, they will advance and I will not if I don't use it, and I will not be able to compete. Well, but if I have to rely on AI to perform it, can it perform without me? Does it even need me? So am I even needed? Am I for the thought process from I want to advance in my career towards am I even needed as a young person? Is there any future for me in my passion? Is there any future in me for science, in science? Is not so far away. And this question, that should frighten many of you, because am I even needed? If a young person asks itself, am I even needed anymore? That's the moment where we have to intervene. We have to say, no, that's not how it works. Because if a young scientist asks itself, am I even needed in its system, and just drops out and says, no, this is not where I want to be, this is really bad. And so your head might end up in this state where everything's on fire and you don't really know what you want to do, but you still want to find a solution somehow. So how can we help? So what can we do really? And this needs a strategic approach. This is not simply done. I believe, in my personal decision, this is about allowance. That's not about allowance or restriction. It's about guidance. Now we have the problem. We are the generation of AI. We're born in it. Most of the advanced scientists, they're not born in it. That AI is something new. So you should start with awareness. That's the first thing. You should be aware of the problem that the use of AI is difficult and complex. That's where you should start. Most of us, if you're an advanced researcher, is likely not educated in AI, but this is needed if you want to help young researchers to not end up in a situation where they say, I don't need to be here anymore. I am not needed. Then you need to educate yourself about what AI can do and what's the impact of it. The next point is you have to create an aura of well-being around. Talking about AI and talking about the fact that I used AI for my last proceeding and I feel really bad about it because now I got the money, but I don't know whether I really deserve it. talking about that topic is not easy. So you are of, well, you have to be educated on the topic, talk about, otherwise you cannot create that out. And then last point is you have to develop together with the young researcher consciousness, so that you take conscious decisions every time you use it, and you ask yourself, really, is that the moment I need to use AI, and why do I have to use it, and what is the impact of that? Consciously use AI, sustainable, and hurt anyone. So the first is, all of this, first point is, are heavily impacted by artificial, and they're caught between loss of identity, and sometimes they end up losing their own navigation in life towards what they really want and what they can really do and where they really need it. So therefore, it's on all of us to first become aware of that this is a problem. This is a big problem. Second, that all of us have to become educated on the field, educate ourselves on the subject. We have to develop an aura of well-being around the topic of artificial intelligence, and we have to foster consciousness on the use of AI among students and among ourselves, among the established researchers. And that is the statement I want to make today, and I want you to take home in this presentation. If you don't take home anything, if you haven't paid attention for the last 20 minutes, that's perfectly fine. I don't care. If you take that statement home and you at least keep it in mind a little bit the next time your young student talks about AI, I'm very happy. And with that, I finished my presentation, and I thank you for your valuable attention. I hope this was also valuable to you.
Thank you, Cyrus. I think that we speaker, then we go to the coffee break, and we come back for the questions and the discussion with the speakers present.
No, I actually did them by hand. This is why I've got like 5 emails saying, where's your slides? Upload them, please.
Okay. So, no longer young, yeah. Okay, so our next speaker is Geraldine Cochrane. She's a professor at Ohio State University, is a fellow of the American Physical Society and of the American Association of Physics Teachers. She has great experience conducting equity-oriented physics education at various levels, including high school, colleges, graduate studies. She also investigates the experience of marginalized people along their academic pathways. She has also developed programs to make physics more equitable. She's a member of the Inclusive Graduate Education Network Hub and a co-PI of the National Science Foundation funded Inclusive Graduate Programs in Physics project. So thank you, Geraldine, for having come here. The floor is yours.
Thank you. And thank you, Sylvina, for the introduction. I actually want to start with acknowledgements. So for one, I really appreciated the speakers that participated in this intercommission symposium, both yesterday and today. I have found it very inspiring. I also want to thank the audience that's here today because I'm going to be talking about my field, which is equity-oriented physics education research. So I really appreciate the opportunity to talk to you all about this topic. And then finally, I want to thank the previous speakers who kind of already established for me what is the motivation for the work that I want to share. So environmental harm disproportionately impacts marginalized households. I think about Inez's talk yesterday when she mentioned, like, even within rich countries, those who are disproportionately vulnerable, right, who are the most vulnerable, are often impacted by environmental harm. I also think about Michelle S.'s presentation on discussion of the Earth Humanity Coalition and the need to understand the experiences and the knowledge of the local communities and indigenous knowledge and the knowledge of marginalized people. And so for me, all of these things make physics education incredibly important because physics education allows for social economic mobility. Research shows that people who are located in areas where there is a disproportionate impact of environmental harm often can't leave these areas because of financial reasons. And we know that a career in physics, right, can lead to social mobility. So that means physics education is important. And then there's also physics education providing an opportunity for those who are impacted by environmental harm to address the issues that are important to them, that are important to their families, that are important to their communities. And then I'll also add from Anna Maria's discussion, physicists have power. Physicists have power to make change. And so thinking again, how do we educate more broadly people to participate in this power and make decisions and make change? And so for me, this also means that equity-oriented physics education is incredibly important. So just kind of two disclaimers here. One, the majority of my research focuses on physics education in the United States. So I'm going to be drawing from that today. Although I know from literature and work done by others that the problems I'm going to talk about are in the States. The other thing is I do human subjects research. I'm going to engage in storytelling rather than just citing all the research studies. And so I'm going to present to you a story of Judy. So Judy is like me. She's an African-American woman. Her family was devastatingly Katrina in Louisiana. So Judy wanted to become a physicist so that she could conduct sustainability research. Very bright student who excelled in all of her math and science courses in middle school. And Judy goes on to earn a PhD in physics and decides that she no longer wants to be a physicist or participate in the physics community. So there's a gap in that story. And I want to share that gap. And although this is a hypothetical situation, it is grounded in research, equity-oriented research in the US. So I kind of left a note of Judy being a very bright student in science courses in middle school. So let me. Although Judy excelled in the math and science courses, the two did not. There's some institution middle schools in the US in Algebra 2, but Judy's school is financially disadvantaged. So she doesn't have an opportunity to take these courses in middle school. In fact, Judy's high school doesn't offer Algebra 1, let alone Algebra 2, or geometry, or trigonometry, or pre-calculus. So when Judy starts college and says she wants to major in physics, her advisor says, you should reconsider. I don't think you should do anything in the STEM fields because it's going to take you 2 years of catching up in math before we'll ever let you take a calculus-based physics course. And in fact, Judy's high school didn't offer physics either. and she happened to enroll at one of the universities in the United States that doesn't allow you to take calculus-based physics unless you took physics in high school. And so Judy is appropriately frustrated by this, but she takes those extra couple years. She takes courses at the community college. She takes courses over the summer, and now she's in her 3rd year and she's actually taking the introductory physics sequence. But now she's in the class and she's working with group members, and she's finding that she's facing sexual harassment because she's in a course that is predominated by men, and they make comments, sexist comments. She's subject to gendered microaggressions in the classroom. And so before I continue on with her study or with her story, I'll just back some of this up. So I mentioned that Judy doesn't have access to Algebra 1 or any advanced math courses in high school, and Judy's high school didn't offer physics either. So based on a report from the U.S. Department of Education Office of Civil Rights, only 53% of public high schools in the United States, only 53%, excuse me, public high school students in the United States attend a public school that offers a full range of math and science courses. Only 87% of U.S. public high schools actually offer Algebra 1, and again, that's let alone Algebra 2, geometry, trigonometry, which are all the requirements that are usually necessary for enrolling in an introductory calculus-based physics course in college. And most public high schools offer a physics course. Story, but Judy. Inequities in access to physics and math at the high school level are exacerbated by policies and practices at the collegiate level. So there's already an inequity at the middle school and high school level because Judy doesn't have access to the courses that she otherwise would want to take. But then that's exacerbated in college when she's now prevented from taking calculus-based physics sequence, which is what's normally required for physics majors. But I'm going to continue on with Judy's story, and I'm going to go through graduate school. So Judy was really excited about getting a PhD in physics, so she knows she has to finish that bachelor's degree. And like I said, she took the courses. She maybe started a couple years late, but she completed her coursework. And now Judy and her friends are thinking about applying to graduate school in physics so that she can earn a PhD in physics. Judy applies to multiple schools, but she doesn't get accepted to any schools. Her friend Jeremy also applies to multiple schools and doesn't get accepted. And Judy can't understand why, because she had a very high GPA. She took all the required courses. She even had research experience and published the conference proceedings with her research advisor. So she thought for sure she was going to get into a PhD program in physics. She reached out to some of the directors of graduate studies in the physics departments in the US, and they told her, well, you know, your school only required 1 semester of quantum mechanics, and we expect 2 semesters. And your school didn't require and you didn't take thermodynamics, and we expect you to have taken thermodynamics as an undergraduate. So she finds out that even though she met the requirements, she did what she was supposed to do for that bachelor's degree in physics, and she even gained research experience. She somehow was not prepared enough to be admitted to graduate physics programs. Now, Judy has a friend, Jeremy, and Jeremy also wasn't accepted. Now, Jeremy was working multiple jobs while Jeremy was an undergrad. So Jeremy's GPA was not as high. And so Jeremy finds out about a program called a bridge program that is really focused on students who are minoritized due to ethnicity and race. And so students in this program can actually take any undergraduate courses that they maybe didn't have as an undergrad before they go into the graduate core. So Judy applies, she gets accepted to the bridge program. She's super excited. She tells her family, I'm going to get a PhD in physics. I just got admitted into the PhD program. She has some work to do because she's in the bridge program. She has to take these courses that she didn't have as an undergrad, but she takes those courses, and now she's in the graduate core courses. She wants to work in a study group. As an undergraduate, she worked in a study group, but now as a graduate student, people don't want to work with her. And worse yet, she's working alone one day, working out homework problems by herself in a corner, and she overhears a faculty member say, the students who are in the bridge program, I don't know how I could teach them. They're the lowest of the low. They're basically the worst students, but we had to accept them. And so this, again, is really disheartening to Judy. But she's adamant about getting her PhD in physics. So she bypasses that, and she finishes her graduate core courses. Now she's taken a written qualifying exam. For the written qualifying exam, she finds us a male student in the program to study with. And she's excited because, again, she enjoyed working in study groups as an undergrad, and this written qualifying exam is very important. So the two of them, they take this exam after studying together. And what they found on the electricity and magnetism portion of the exam was that it was really similar to one of the practice exams that was placed on the website for them to study a few years ago. The interesting thing is, though, after she completed the written qualifying exam and a week later her results come back, what Judy is told is that she passed the other portions of the written exam, but she failed the electricity and magnetism exam. So she's like really bummed out about this because this was the one that for sure she knew she passed. So she talks to Jeremy because, again, the two of them, they study this exam together. And so they go over their answers, and their answers are about the same. And so Judy goes to the department and she says, "Can I see a copy of the exam?" Well, the department's policy is that they don't actually give out copies of the exam, and they won't tell her her actual score. But she knows that Jeremy did the same thing and Jeremy passed. Well, what she later finds out is that the faculty member who graded the electricity and magnetism exam has explicitly stated that women are not as good in physics and that they need to prove themselves by working harder. And so it turns out that all of the female graduate students who took the qualifying exam failed the electricity and magnetism portion that faculty member scored that year. And so that was disheartening to Judy because now she's told, your next year, not only will you have to retake the electricity and magnetism portion of the qualifying exam to continue in the program, you also have to find a research advisor, and you're also going to be on a teaching assistantship another year because you didn't pass the qualifying exam. So now Judy is teaching her class because she really does love teaching, and she actually thinks she wants to be a faculty member. She's studying for the exam, and she's also trying to find a research advisor, which was really difficult. She reached out to people and she didn't get responses. And she later finds out that, again, faculty are hesitant to take on students who participated in bridge programs. She's fortunate, though. She finds an advisor who takes her on, but she's told that she has to work really hard to stay in this program. So Judy's putting in like 70 to 80 hours a week while also doing her teaching, while also preparing for the exam. She works very hard, and it is recognized. So her advisor does bring her on into a research assistantship for the next year. She passes that electricity and magnetism exam. However, she again begins to face sexual harassment and gendered microaggressions in her research group. So fast forward, a few years later, Judy defends her dissertation. She earns her PhD in physics, but she no longer wants to participate in the physics community. I forgot that one, but yeah, undergraduate women in physics face sexual harassment. And so, again, Judy's story is hypothetical, but actually a lot of what I mentioned resonated with my own experience in physics. And also, some of the quotes that I pulled come directly from the participants in the research studies that I cite here. The graduate admissions process in physics often exacerbates existing inequities. This could be due to standardized tests that are used in the graduate admissions process, undergraduate GPA, which we know is relative. I'll give you just one example from my own class. I remember teaching an introductory physics course, and I had two students come up to me after the first day of lecture when I kind of told them what was needed for the semester. And one student said to me, the first one said, I really need to get an A in this class, and I know physics is hard. Can you please tell me what I need to do? Because I'm working 2 jobs this semester. The second student comes up to me and says something slightly similar. He said, I really want to get an A in physics, and I know it's hard. Can you tell me what to do? Because my parents said that if I get an A in physics, they're buying me a brand new car. Those 2 students are both motivated to do well in their introductory physics course, but their experiences are going to be different simply because the way that they're motivated is different, and the amount of time that they actually have to study for the course is different. And so even when we look at undergraduate GPA, we're never comparing apples to apples. The other thing is the opportunities for research experience. Not everyone has that as an undergrad student. Students in bridge programs are often stigmatized by faculty and resented by their peers. And bridge programs, again, are designed to help students who maybe didn't have the same opportunities as an undergrad to be admitted to and successful in PhD physics programs. I mentioned that Judy had a hard time finding a study group. Well, research shows that Black women are excluded from study groups in graduate physics programs. We also found that faculty hesitate to work with students from bridge programs, and physics graduate students in general struggle to find research groups. And then even when their research group is hostile or they're unhappy, they're often afraid to leave their research group for fear of being kicked out of the program or stigmatized by other faculty members. Physics graduate programs also often lack policy regarding days off and vacation for graduate students. So this is how you have some students working 70-hour weeks, 80-hour weeks in their graduate programs. And then finally, women graduate students in physics and astronomy face microaggressions and sexism. And so Ego actually asked me to prepare an upbeat talk. And so it may not seem that way now, but actually, for me, I'm actually very hopeful because what I have seen is that equity-oriented physics education research has improved some things. So just to say a little about equity-oriented physics education research, I think it has a number of goals, and the type of work that I look at, it's various things. Some of it is raising awareness, so uncovering inequities in physics education, like the fact that there are many students who are classified as underprepared in mathematics, who don't have a chance of being a physics major simply because of the high school that they went to. There's also work that's looking at developing strategies for mitigating the impacts of unjust and unfair circumstances, policies, and/or systems. So there I'm thinking about programs like bridge programs, which are designed to support students who don't have the same opportunities and access to education at the undergraduate level. And then finally, providing evidence-based strategies for modifying policies, practices, and then culture to make things more just or fair. And so there are 3 particular networks that I reference here. I'm a member of all 3 of these networks, and they all are based on the work of physics education research. And so the first one, the acronym we use for that is TIPS, Transforming Introductory Physics Sequences to support all students. One of the major changes there is removing barriers to accessing calculus-based physics courses. So you may be wondering, how do you teach a calculus-based physics course if a student is not or pre-enrolled in calculus? Well, we teach them the math in the physics course. Oftentimes, students who have taken algebra, pre-calculus, and calculus, and even especially trigonometry in the intro physics course, they need a more thorough understanding, and they also need an understanding of how we use these mathematical skills in a physics context. So rather than using those prerequisites for math as a barrier to allowing these students to enter an introductory physics course, we don't fix the student, we fix the course and provide the mathematical skills within the course. The other thing is mathematical skills and quantitative literacy are like 2 different concepts. And although we focus a lot on mathematical skills, research shows that it's quantitative literacy that actually causes students to struggle in introductory physics courses. And so we intentionally implement curriculum that's designed to build students' quantitative literacy skills. And so as a part of this network, we develop curriculum, we support faculty who teach transformed courses, particularly for those courses that support students who have what I will just label a diverse background in mathematics. And what I count as a win is that a growing number of physics departments in the US are now removing the calculus pre or co-enrollment requirement for calculus-based mechanics courses. There's also the Inclusive Graduate Education Network, which identifies inequities in the graduate admissions process. They design rubrics to support holistic admissions processes, and it has made an impact. Many departments have changed to using holistic admissions in their graduate admissions process. And I cite here this one article by Young because they actually published what they did at their institution. Their institution is named in the paper. It's Michigan State University. But there are a number of departments, which I found out through the inclusive graduate programs in physics, that literally cite the physics education research studies and say, someone brought this to our faculty meeting and said, we need to change how we do admissions because it's causing barriers for students, and it's also causing it's a hindrance to diversity. And so as a result of this research, policies have been changed, and we know as policies change, practices change, and that is how you change culture. And then finally, I'll mention the Inclusive Graduate Programs and Physics Project. This continues the work on graduate admissions, but it also looks at things like qualifying processes in graduate physics programs. So written qualifying exams, as well as oral candidacy exams. And then it also looks at things like improving culture and climate in graduate physics programs so that we can reduce and hopefully in the future eliminate issues of sexual harassment and gender microaggressions in physics spaces. Before I move from this slide, I want to say one thing, which is the importance of professional societies. So all three of these networks, these are national networks. In fact, the Inclusive Graduate Programs in Physics Project is 15 large physics departments in the US. All of it's funded by the National Science Foundation, but the American Physical Society is a partner in all three of these projects, and they actually developed the pilot for the Inclusive Graduate Education Network. And so here I share some of my selected references on gender harassment because I always get, is that really happening still in physics and at the undergraduate, the graduate level, and within the workplace? And then also I include my references that were mentioned in the presentation. Again, I want to thank you all for the opportunity to share with you all today. I want to acknowledge the National Science Foundation since again, they fund a lot of the research that I referenced that has been published as a part of some of these projects that I mentioned. And with that, I want to thank you again.
So thank you, Geraldine. And so we go to the coffee break and come back at 4 for the question and discussion session chaired by Sunil. Welcome back. Thank you. So we will now have the discussion session and the questions. So I think Ana Maria is not here, but we have Geraldine and Cyrus. And now this session will be moderated by Sunil. So I hand over the microphone.
Thank you, Silvina. I think we all can agree that we had a really stimulating 3 days, not only General Assembly, but the other sessions, which were really exciting. We had some questions and answers during the first 2 days. But before we get into today's talks, and 2 of our speakers are here on this side, I just wanted to mention that, we had really broad themes that we covered during this GA, probably more than ever before. So we had, if I were to categorize, we could broadly say they fall into 3 different categories. One was diversity, equity, and inclusion. And then there was many talks on that issue on the very first day and the following days. And then there was discussions on sustainable planet, sustainability, energy use, and so on and so forth. And finally, we had many talks on technology, so on fusion, on quantum sciences, AI today. And so we really had a full plate. And I know 30 minutes is not enough, so I won't take any more time. I think first we will offer the opportunity. Is Professor Chetto joining? She is not there.
I haven't seen her.
Okay. Yeah. So I think if you have any comments or questions for either Cyrus or Professor Kochanan, you could raise your hand or comments. Pietro.
Okay. I have a question for the talk about the situation for education, in particular for undergraduate students. Great talk. I have an idea. I think what is also important.
To whom this question is directed?
To her.
Okay. Thank you.
Even if you have a perfect system with algebra to everything, you have to give the opportunity to the people to have access to that. So my feeling is that you can create the best system in the world for education, but if normal people normal students, young people do not have the opportunities, the chance to access that, we will never sort it out, the problem of the diversity, the exclusion. So just maybe you can make a comment to that.
Thank you for that. Yes, I think that is very true, right? That even when you have schools that prepare students well, not everyone can attend those schools. I think for me, as a faculty member, I hear a lot of faculty say, like, we have these students are not ready before they get to college. And so I think, like, there's a lot of work to be done before students, like in the US case, but that doesn't mean that, like, there's something that there's nothing that we can do at the collegiate level. So, okay, sorry. So I guess what I'm thinking is we have these inequities that exist in terms of access, right? So even if we have a school that prepares students well, not everyone gets to go to that school, right? So I guess for me, the thing is thinking about knowing that's true until we can fix that system, like, what policies and practices can we do to mitigate the negative impact of inequities, right? I mean, the ultimate goal is to eliminate the inequities, but that's often harder to do than thinking about what can we do to mitigate the negative impact. And so I guess that's the way I think about it, because you're right, the systems are not perfect, and to change the systems often take time. And so I think about what policies or practices can, like I say, mitigate the negative impact of the inequity until it can be eliminated.
I think my phone is right there. Please. Oh, Jens, I'm sorry. Jens, please.
Thank you.
I have a follow-up on that. I have a follow-up. Okay.
Sorry.
Okay, go ahead.
No, just an observation out of my own experience. I'm professor in Switzerland. We have we could say one of the best possible education.
Can you keep the mic closer?
We have one of the best possible education system. We have young kids that grew up, they have access to all and everything they need. And what I realize is to hire Swiss people is very hard. And when you hire them, they don't have the energy because overspoiled. So this is an observation from the opposite. I like to hire people who have had a bit more tough life until I hire them, because then I know they will be resilient. They will go through, they will accept struggle and perform and succeed. So just as a piece of information to hope it gives you hope.
Thank you. It does. Used to holding the mic. Resiliency. Kind of what you're talking about. There's a framework by Tara Yasso, Community Cultural Wealth, that talks about the various forms of capital that people from marginalized ethnic and racial groups bring to educational settings. And one of them is like resilience and resistance capital, navigational capital, like how to navigate when you're faced with tough challenges. I think the thing I advocate for, though, is like struggling through a physics problem also teaches you resilience, right? And so I agree with you wholeheartedly that people who sometimes face the marginalization develop this strength that supports them in the workplace, like you say. But I'm still an advocate for changing those environments and challenging people in other ways. I'd rather stick them with hard physics problems and say, like, learn the joy of getting through, sticking out a problem until you can figure it out, versus like, how do I navigate, moving on to the next area of my career or academia when I have all these barriers.
So what you're saying is the system is so badly skewed that some people just don't have a chance to progress at some level. Is that because being faced with challenge is one thing, but then being so overwhelmingly, deprived of opportunities is the other extreme. So one has to have somewhere balance.
Yeah, I wouldn't say that it's so skewed that some people don't have any opportunity to. I don't know of that, is what I'll say. What I can say is the research that I do is often on finished. These are the people who finish their bachelor's degrees. And so it's not that they're well, it depends on how you want to define success. But I'm going to say it's not that they're not successful, it's that they're successful in spite of the challenges.
Jens.
Yes, so, thank you. So I have a comment to Cyrus' presentation, which I enjoyed a lot, I must say. And I think it's very important that we create a safe environment for students to use artificial intelligence. And just as an anecdote to illustrate that, I met a professor from Germany, actually, in the CERN restaurant a few weeks ago. And we were discussing artificial intelligence. And he said he had been discussing with his students. And then he asked one of his students, so are you using artificial intelligence? And the student got a bit in panic, And before the student could answer, the professor said, I really hope you do. If not, all your colleagues will be better than you.
Well, so first of all, thank you very much I really like that you enjoyed my talk. That was what it was for. So I think there are so many facets to that statement and also to that encounter. Let me focus only on those that are really directly related to AI. And the first thing is that is exactly that moment where you don't have a safe environment to talk about AI, because it doesn't matter what you say in that moment. You are not comfortable with talking about whatever you use AI for, what you don't use it for. So it's really about exactly that. It's creating that area where people are just happy to speak about that topic freely without you pushing them for it. It can just be this open area, this community where everybody can openly talk safely about what they do. And it's also about talking about struggles. It's not only about, oh, I use it there or I use it here. It's also about communicating, hey, I do have these struggles. I do have these doubts with myself. I do wonder whether I'm a good researcher. If I write my proposals and abstracts for my next conference with AI, would I be accepted without it? It's really about talking about struggles and situations and where we are. And that is the prime example on how it should not work. Thank you very much, Jens.
Okay, before we go to Rudolf, I just want to mention that Professor Anna Chetto has joined, so we can also direct questions to her. So Rudolf, and after that, Prajwal.
Sorry, it was on mute. Thank you for the presentations. I think it's been excellent. I specifically have a comment or a comment and a question to Geraldine. In South Africa, the South African Institute of Physics, we've got a fairly successful physics teacher development program for secondary schools. What we are now starting to get involved with, and it may sound strange, is looking at science education at the ECD level, so early childhood development. Because what has been found with research is that although science teaching at that level is part of the curriculum that has to be taught, many of the teachers are either not been trained to teach that, or they themselves are so uncomfortable with the concepts that need to be taught that it just gets skipped. And so other research has shown that if children have not been exposed to science before the age of 7, then they don't really consider that seriously as a career option going forward. So for that reason, we've now contracted with the University of Venda, where they've specifically looking at and have experience with that, so that we can start supporting that level of education. I don't know if you've got similar experiences from the US. Thank you.
Yes. So while I don't do research in that area, there is a group of folks in physics education research in the US that are looking at that area and doing curriculum development and also creating workshops so that the elementary school teachers feel comfortable introducing the topics, and not just the physical science concepts, but again, I'll just mention the quantitative literacy. We know that math skills are important, and like math is included in the curriculum, but it's almost an assumption that students will gain quantitative literacy skills. So like we don't actually teach them directly in math classes, and we don't teach them directly in physics classes either. And so that's another thing, that there's a push now for teaching quantitative literacy in the elementary schools also.
Would it be all right for me if I comment for a second on that? Yeah, because I absolutely want to underline that, and I would just wanted to report from my personal experience, because for the last 2 years, I was teaching at my universities, those people who become elementary school teachers, for just coincidence. And they have to attend a subject called physics and technology, and they are frightened to the bone. These are a lot of the people I talked to, they said physics was the end boss. And I've deleted it as soon as I could in high school, as soon as I could. And now it's back. It's like the end boss I've never really defeated, because they have to do the subject in order to teach a subject called natural sciences. So they have to pass that class. And they say I talk to many of them. They say, if I'm a teacher in elementary school, I will not do a physics project. I can, like, for the whole third and fourth year, I can teach whatever I want. I will not do a single physics project. I will show them how, like, leaves are working, how biology is, a little bit of maybe the minimal thing I would maybe do is talk about the solar system. But anything else, I will not touch physics because that's frightening and I don't want to touch that. And that's what we were doing for the whole semester with them, making sure they're not scared of physics anymore. So that is just, I can really relate with both of your comments so much. That was my reality for the last 2 years.
Thank you, Cyrus. Prajwal?
I actually had two comments, as I had a comment each on each of the presentations. So I think Geraldine did an amazing job of, and a compelling argument as well, that we have to front and center the concerns that she raised. My question is actually to the IUPAP executive as to how much these are centered through the Commission on Education. And my question to Cyrus was, I fully agree with you about the last bit that you talked about, for the individual, the business of awareness and critical thinking and all of that. But isn't the elephant in the room really the private ownership of AI, and shouldn't IUPAP be striving towards public ownership, publicly owned AI? I wanted to quote Kentaro Toyama in this context, who's an information technology expert and professor in the University of Michigan, I think, who says that technology always amplifies the underlying socio-cultural economic framework. So if it is an inequitable framework, technology will amplify that. And if it's an equitable framework, it'll amplify that. And I mean, that sort of encapsulates, I think, the direction in which IUPAP should move forward, right? I mean, because that's really the elephant in the room, that current AI, I mean, you talked about AI as if it was one thing, but actually AI is owned differently in different frameworks. There is a movement to push for publicly owned AI, and shouldn't we be making that choice as IUPAP?
So should I answer the first one? Okay. So the Commission on Physics Education, they issue a report in which they include some recommendations for the teaching of physics at various levels. But I think that we have to rethink a little bit if we want to increase the impact because physics education at secondary or high school or middle school or elementary school level is something at national or even within nations at provincial level, I don't know. But in order to have an impact on that, I think that we need to rethink a little bit the structure, because Physics Education Commission is mostly about research on physics education. And then if we want to impact on the school systems, it's more at the national level. And I was thinking that maybe a structure a little bit like what the Working Group on Women in Physics did, with a network of working groups per country, we could have a greater impact on physics education at the national level, which will require translation, of course. And so it's something that we will discuss with the evaluation and restructuring. And so let me ask something, and then we move to your second question. I wanted to ask Geraldine, you can answer after Cyrus responds to Prajwal, so that I have the mic. I've noticed that there is this bridge program trying to overcome or reduce inequalities, but then that's detrimental of the students that are part of that bridge program because of the biases of the professors that think, oh, these kids, I mean, come through the bridge program, surely they are not good, I have to make them pass, but they are not good. How do you think that would be the best? Should we be not disclosed that people come through the bridge program? What would be the best way to moderate the effect of those negative biases? So I give the mic to Cyrus and then.
You will be the next. Okay, Cyrus, you go ahead. You answer Prajwal's question.
Okay, thank you. So thank you very much for that question. And That is a really difficult question. So I really enjoyed the fact that Silvina was taking first a little bit of time so I could think a little bit. Because talking about public AI, and you're right, AI is, there's not the AI, it's just all over the place. It's everywhere. It's developed in many, many private companies around the world. It's developed in many, many research institutions around the world, and it's really vast. I would not dare just say that I have an idea on how the landscape looks right now, because the landscape changes so rapidly. It's basically impossible to always keep a good track on what's going on. I believe, as much as I know about the topic, public AI is a really difficult question. It's, if you're not in the field, I believe it's very hard to answer, and I also don't count myself into that field, because that's really, there are people that think about how to make AI public for the public good, and at the same time I would love to learn more about the topics. I would probably say in that moment that I would come back to you with more insights on that at some point, because that is a very difficult question, and I would say you deserve a proper answer on that one, and I can't give you one right now.
Okay. Okay.
Yeah. So what you said about an answer to the bridge program. So I don't think the answer is not disclosing if students participate in the bridge program or not, because there's really nothing negative about that identity. I think it makes sense that if a student, doesn't have an opportunity to take a course as an undergrad, that they have the chance to do it as a graduate student, or in some cases it's about research experience. And so I don't know how common this is to have to take implicit bias training. I have taken this. Has anybody taken implicit bias training before? Okay, very few people. But what I'll say about it, at least many of the trainings I've gone through in the US, they kind of tell you that implicit bias is a thing, and then they leave it at that. They don't tell you what you can do to mitigate the negative impacts of implicit bias, or to, address your own bias. And so I think that is what I would actually suggest. So one of the things that research shows works is counter stereotyping. And so right now, at least the bridge programs have now graduated a number of students, some of which have stayed in physics, some that have not, but they finished their PhDs, and many of them did good work and they published good papers. So I think it's more so educating the faculty and putting those counter stereotypes in front of them and saying, these people went through the bridge program and they did really high quality work, and so that they can address their own biases against students who go through the bridge program, rather than hiding the facts, because it's not something that the students should be ashamed of.
Okay, thank you, Geraldine. Just one second. I think Professor Anna is there online. Do you want to make any comment?
Thank you.
Please go ahead.
Thank you. Yes, well, I have been listening to the discussion, and I am ready to answer any question or listen to comments to my talk, if there are any.
Okay. Okay. Thank you. So we'll come back to you.
Yes.
Okay.
Yes. Sorry, but. There are two things that Cyrus and Geraldine really struck me. One was that Cyrus said that young people...
To whom this is directed? The question?
Cyrus and Geraldine.
Okay.
I'm sorry, it's not for Anna Maria.
Please go ahead.
That young people take naturally to AI. Well, I know, because they learn the computer and all that very easily. And secondly, that in the US, I was very much surprised that there's such a low proportion of schools that offer the physical math courses. And so that brought me back to what I said the day before yesterday, is that we should start teaching physics to people when they're kids. This was actually inspired by a quote from Deng Xiaoping of China, who said that we should start teaching computer science in schools to kids. And I think that why cannot we start physics in primary school? Because, you know, when I was in England, the first physics lesson I had was when I was 11. It was on Archimedes and the Eureka. And I was so thrilled that with the simple maths that I already knew, I could actually calculate the density of matter. That was really what started my interest in physics. And I think it's not so difficult for children to accept that. You know, there's a story in ancient China of they were wondering how to measure the weight of an elephant. And then it was a young child who said, well, we can put him in a boat. And then after he comes out, we can put in stones into the boat until the boat sinks to the level the elephant gave. That's a brilliant idea. And it was thought up by a child, or so the stories goes. So I think that we should really introduce physics into primary school before the children have lost their natural curiosity about science, before they have been exposed to the biases and prejudices and stereotypes of society. Okay, that's what I want to say. It's maybe a bit futuristic for IUPAP to undertake this resolution, but I think we should consider it. Thank you.
Yeah.
Thank you.
Somebody wants to answer, or is it just a comment?
I would love to give a comment actually on that.
Okay. Go ahead.
Do you want? Okay. So what I would have loved to underline is the fact that little children come to the world with a natural born curiosity, and this curiosity is the curiosity that makes us curious about learning more of science. This is what we all have that advances, that makes us advance and struggle on with all of the science that we do every day. And I believe we have to foster and carefully foster this curiosity of young students and young children, and let them not have this lost. Because I believe if you have once lost this curiosity in a child, it will be very difficult to reignite that flame. And that's really, really where I believe science needs to start, at the point where normally this curiosity gets lost. This is what we have to nurture. Thank you.
Okay, Anna.
Yes, thank you so much to the three speakers. I feel that the three talks were so different in terms of the topics. Related to Ana Maria, the first talk, good luck trying to make an impact. You know, in that regard, I feel that the system is designed on a lot of defense and national security. Just 40%, I mean, out of the total R&D budget in the United States, 40% goes into Department of Defense. And that's something that it makes no difference who is the president or policymakers. It doesn't vary, okay, between different political parties. So that's why I say good luck. To the second speaker, congratulations. I think you nail it in terms you are talking about a topic that is coming at the speed of light, and that I hope many STEM communities address soon, because if you don't set up the rules on AI, someone else is going to set it up for you. I think you're going to have to educate a lot. You probably are dealing with a lot of faculty members that are teaching you and they don't know what AI is about. So that's going to be on you and all this new generation. We are anticipating that by the year 2050, most of the STEM jobs created are going to be either on artificial intelligence, machine learning, or quantum computing and technology. So keep working on that awareness, all right? And to the last speaker, you know, Geraldine, it's just, we have some of the best universities in the United States, but in terms of primary and secondary STEM education, we're lagging behind. The resources are not there. Depending on where you live is what school your kid goes. We know that in the United States, wealthy families, the resources sent to the public schools where the wealthy families live are much greater, and the best teachers are allocated there versus where low income, where a lot of the White House under Obama administration issued a report that is fantastic, and they identified that there are 2,000 high schools where most of the minorities are pursuing their education, and they define them as dropout factories. We really need to work with school teachers on those areas, provide more resources. And as you know, we don't have national curriculum or standards, right? So that we spend a lot of time in the United States aligning. And the most important teachers are in the life of elementary school and kindergarten. If IUPAP could do something, C14, right, physics education, to develop programs to help teachers generate material that teachers can download and use in the classroom, I think that would be very helpful. In terms of increasing the number of underserved communities pursuing, degrees at the universities, I think IUPAP could develop the women's group mentorship programs. And that will be very helpful. I think changing the system is gonna take a long time. But what we can do is groom a next generation that are more resilient and able to overcome the barriers and challenges. Thank you so much.
Yes, I would like to respond to what has just been said.
Oh, please go ahead. Rosanna, please go ahead.
Do you hear me?
Yeah, please go ahead. We can hear you. Can you unmute yourself and speak?
Yes. Okay, thank you. Yes, the person who just spoke said that she wishes me good luck, but I think it is more than good luck what we need, because as I recalled, there's a IUPAP statement saying that no scientist should be excluded from conferences as long as he carries out work not contributing to weapons development, and that no scientist shall be excluded from the scientific community as long as their work is based on ethics and the principles of science in its highest ideals. So I think we have to really reflect, be self-conscious and self-critical about what we are doing as a physics community. And that's why I think the comments of the person who spoke after my talk with some suggestions of what the working group number 18 should do, should somehow be taken into account, and not by simply a working group, but by a commission. By the way, when I mentioned that there are 19 IUPAP commissions, somebody in the floor corrected me and said there were 18. But according to the website, there are 20 commissions plus 18 inter-union commissions. So I think we can have one more commission that really takes care of these issues of ethics in physics, and in particular the ethics related to nuclear weapons development, spread, and elimination. Thank you.
Okay, so I would just say, in response to Anna, what Anna said about education in the U.S., it's spot on, right, in terms of the challenges. And I think that it'll take multiple strategies to support students who are in the system until the system changes. And like you said, it takes a long time to change systems, but I'm a physics education researcher, so obviously, right, I really do believe, and I have seen, and that's the thing, I have seen changes. I've seen changes in policies within departments. I've seen changes in practices. I've interviewed faculty and asked them, why did you make this change? Why did you do this? And sometimes people are really unaware. even when I talk about the statistics, you know, these things about access, you know, in the US when it comes to education, but there's some faculty and I think people in general who are just completely unaware of the issue. And so I think raising awareness of the issue along with the things you said are definitely important. If I could actually ask a question to Cyrus about his presentation. So I really appreciated your presentation for a number of reasons. There are a lot of things I've learned, but one that was funny is that I'm not a young person anymore because I realized like I'm not aware of the things that you mentioned in your talk. And the few things I know about is because my students have mentioned them to me, in particular, ChatGPT. And so you gave some suggestions for what we could do in terms of helping researchers. So I was wondering if you could expand that to think about how do we support faculty? Because one of the questions that I recently had from students, I have some students who don't want ChatGPT in the class because they feel like it gives some students an unfair advantage if they use it. And I have other students who say, well, I like the way it explains things and it gives me, you know, help when I'm doing my homework at home and I can't ask the professor to explain it to me. And so if you have any thoughts on that, I'd appreciate it.
Before you answer, I think Atlas has been waiting for a long time to ask.
Yes, thank you. This is both first an anecdote and then a question. In regards to teaching physics to students earlier in life, we have noticed the trend.
To whom your question is directed?
Huh?
Question or comment?
More of an anecdote.
And is it directed to anybody specific?
Yes, the last speaker on education. So in Denmark, we've noticed a trend among physicists, which is that when my dad went to university and did his PhD in physics, he had 8 friends, all of whom have kids, and every single one of those kids are now also physicists, with the exception of one who's now a mathematician. So there's this trend of physicists have children that grow up to become physicists because the children are exposed to physics from, you know, when they're old enough to speak and ask questions about the world. So I think that having exposure as early as possible to physics really aids in the sort of the motivation to get into physics.
Thank you for sharing that. I think that's true. I can't recall the survey, but there was the results of the survey, but there was a survey that looked at physics faculty in the US, and it was a similar thing. Not only that people who earned PhDs in physics had family members with PhDs in physics or engineering or a similar STEM degree, but they also were married to people with PhDs in STEM degrees. So I can't recall exactly what survey, but I found it interesting. I think it's more than exposure though. There's also like how to navigate academia that you learn when you have someone like that form of social capital. I think of one of my former colleagues whose daughter finished her PhD in physics. And he said, you know, when she had an issue with her advisor and she wanted to know how do I send this email or how do I address it, she could, you know, contact her dad and be, you know, and he'd give her advice on how to write that email. And so that form of social capital helps with navigating the challenges, not just the exposure. But for people who maybe are the first in their family to go to college, when they face these challenges in academia, even if they have that early interest, they don't have that support on how to navigate academia. So thank you for sharing that. And I agree that when that resource is available, it can support, you know, people in pursuing physics.
Please go
ahead. I still own Geraldine an answer. So yes. I think so. Check.
Yeah.
Yes. So yes, I believe what you said is important. I believe also there are multiple steps you have to take, and the one I would probably start with is amongst the faculty members create a feeling of that it's okay that we have to talk about this topic now. That's so this whole idea of making sure that the communication gets better about AI drops in the moment where a faculty member doesn't want to do it anymore. Because sometimes you have faculty members that have their very own will and say, no, I don't want to have to do anything with AI because I'm feared to take my job. So if you first can create that openness, in a second point, you could teach them and you could advance their knowledge so that they actually have some background on how to deal with the situation in class. Because it doesn't help anything if you have the knowledge, if they don't have the knowledge in the classroom in the moment the problem arises. They cannot do anything about it, and they're out of the depth to really deal with it. So I believe after you have had the chance to create an open environment, you can teach them, and then they can, in the moment, adjust the situation in such a way that it's fair for all of them. Because you cannot completely ban ChatGPT out of the classroom. It's very hard to control that. Just restriction is most of the time very difficult, a very bad idea for new technology because people will find a way to use it and always have in the past. So making it in a, again, manner that is aware, like it's an awareness matter about how to use it and have a conscious use of it. I believe that's where you want to move and develop towards. And that starts with creating openness among the faculty members, at least for me.
Okay, thank you, Cyrus. We are almost out of time, but one last question from Egle. Please keep it very brief. We are already over the time. And also mention who it is addressed to. And brief answer, please.
Thank you. It's a comment addressed to my colleagues present in the room.
Closer.
It's a comment addressed to my colleagues in the room. Geraldine, thank you. You raised many challenges faced in the story of Judy. My colleagues might think that the prevalence of sexual harassment in physics is rather low and that her experience was unusual. I have figures from the global survey, and for physics, for men respondents self-identified said they were subjected to sexual harassment 2% of the, 2% of the respondents said they were, whereas for women, the figure is 29% answered yes to the question, have you personally experienced sexual harassment? And that was in a survey with 32,000 respondents in 159 countries. And so we ask, what can we do? We can change the environment and we can offer tools. I think we can offer coping mechanisms for everyone, and we can make environments in which this does not happen. Do you think that's okay? Do you have other suggestions?
Would you like to answer or comment?
Sorry, I didn't realize that that question was for me. But yes, I do think changing the environment it's imperative, right? I think not everybody wants to be in physics, right? Not everyone wants to do physics. So if someone wants to do physics, should we not work to create an environment where they're safe to do physics? So yes, I 100% agree with you on the fact that to change the environment. But the thing is, that's it's the same as when we talked about educational access. It's hard to change the environment. It's hard to change the culture, but we have to start somewhere. And one place I think is awareness. So like the survey that you mentioned, and there's a lot of resources, right? There are a lot of research that shows harassment is happening. And yet, like, I've run into a lot of people who tell me like that, like they're just shocked. You know, they're shocked by the numbers or shocked that it exists. So I think part of it is raising awareness, but also understanding what sexual harassment is. And it was actually, I believe it was the National Academy's report where they defined the difference between, well, they define all the various ways in which sexual harassment can happen. There's sexual assaults, there's sexual microaggressions, and I'm not listing all of them, but it's there in the report. And so I think that like having that awareness and education allows to even have the conversation, because there are people who might sexually harass other people because they don't actually recognize that it's sexual harassment or that something is wrong. And so I think education is necessary for those cases. And then there are people who absolutely know what they're doing and they need to be stopped. And so that's where policies need to come into place. And that's where I think, you know, within certain organizations that depending on the kinds of organizations, that can be very difficult. I think about what happens in industry versus in academic settings versus in like national labs within the US, right? Efforts to address and to create policies to prevent sexual harassment, and the fact that there are still serial harassers that people are aware of, right? Those are the areas where, again, people in power have to implement policies to make the change so that we can get to the point where the environment is better. So
thank you, Geraldine. I think we'll have to wind up. I'm sorry, we really are out of time. Oh, what is that? Who's that?
I don't know. There is no more time.
I think, yeah, we have to wind up, otherwise.
Really, we have to finish because in 15 minutes from now, we have the presentation of the book, so we cannot stay much longer.
I would like to really thank our panelists here, as well as Anna and all of you. Thank you very much.
So,
thank you. Goodbye.
Thank you, Anna. So let me say a few final words to wrap up this very, very interesting activity. The aim was to understand what physics and physicists could do to make this world that we live in a better world. And as Giorgio Parisi said yesterday, it's not just about physics, it's also what physicists can do beyond physics. And we can contribute to understand better how climate change occurs, to contribute to sustainable development, to help prevent war, to help reduce inequalities, to improve the quality of education, or help improve the quality of education. Yesterday, we heard amazing talks about climate change, geohazards, energy for the future, new technologies and materials. And today we heard about justice and education, AI, and also the possibility of having a nuclear war and how to prevent that from happening. And Giorgio Parisi, I think, yesterday gave an amazing talk. I took several notes. I'm going just to share a few of them because he addressed many of the issues that were addressed in this meeting. In particular, he said that still we need to model better various of the physics processes that affect climate. We need to have a better understanding of what we call tipping points. The current knowledge has been tuned to predict what is happening now. And maybe there are other phenomena that we don't know that can have a catastrophic effect. For that, we need a basic physics understanding. Sometimes the machine learning techniques gives us a black box understanding. And I don't know how much they can predict these tipping points. For that, we need our brain power to get models that give accurate predictions. He also talked about teaching science with hands-on from an early age that was mentioned in this session too. And he said the primary function of school is to form citizens that can take informed decisions. And I think that we all have to contribute to that. He said if every physicist spent 5% of her daytime trying to communicate to people, change could be induced. So I think that we should try to engage ourselves in science outreach, in explaining also how science is made, this human endeavor that we are all in to make our world a better one. Thank you.
Thank you, Silvina. And with that, we close this session.
your presentation. So we come back in 15 minutes for the presentation of the book by Roberto Lalli.
I'm so sorry. 35 minutes and it's just 42 minutes. Yeah. I wanted to say it's a chance to know you're right. Would you like to display on the screen? Yes, thank you. This is something I wrote many. Oh, okay. You can see it in South Korea. Okay. You know, in New York. Okay. It's there in the South Korea book. Yes, so 7 years back. Yeah, but this group, I made this group from a formal